All right, let's talk about one of the most tedious parts of being a developer, writing the same exact test over and over again. Well, today we're diving into a really powerful feature in JUnit 5 that's designed to kill that repetition for good. We're talking dynamic tests. Let's get into it.
You know the drill, right? You've just built a new API endpoint. It's almost identical to 5 others, so what do? You hunt down an existing test. You copy that whole block of code. You paste it. And then the fun begins, carefully changing the URL, tweaking the expected values. We've all done it. It's practically a developer ritual.
But here's the thing. That shortcut is actually a trap. It's what our source for this explainer calls toil. That boring, repetitive work that just grinds you down. And even worse, it's so easy to forget to update one little line, and suddenly you've got a test that passes, but is actually testing the wrong thing entirely. So today, we're going to build a much better way.
Okay, so here's our game plan. First, we're going to talk about a whole new way of thinking, treating our tests like a factory. Then, we'll get our hands dirty and apply that thinking to a real-world problem. After that, we'll see how to keep our test reports nice and clean, and finally, we'll nail down the one big signal that tells you exactly when you should be using this stuff.
So the very first step here is a big mental shift. With dynamic testing, you stop being a test writer and you become a test builder. Think about that. You're no longer writing individual tests one by one, you're writing a machine that generates them for you.
Let's just make this super clear. A standard @test method, the one we all know and love, is the test. The code you write inside it, that's what JUnit runs. But a method annotated with that test factory is totally different. It doesn't run any test logic itself. Its only job is to produce a bunch of tests at runtime, which JUnit then takes and executes for you. It's a factory, not the product.
And here's the key technical detail. A @test factory method has to return some kind of collection. It could be a list, a stream, whatever. And that collection needs to be filled with special objects that represent the tests you want to run. These things are called dynamic nodes.
Think of these as our Lego bricks. Dynamic node is just the base type. The two real pieces we're going to use are dynamic test, that's the actual runnable test with a name and the code to execute, and dynamic container. We'll come back to that one in a bit, but it's our secret weapon for keeping things organized. All right, that's enough theory. Let's make this real. We're going to walk through a super practical scenario, automatically generating tests to make sure that every single post endpoint in our API accepts the content types it's supposed to, like JSON and XML.
And you know what? The logic here is surprisingly simple. Our test factory is going to do 3 things. First, it'll scan our whole project to find all the API controllers. Second, it'll create some simple dummy objects for any dependencies those controllers need. And finally, for every controller it finds, it'll locate all the post endpoints and automatically generate our tests.
Now, this is the really clever part of the whole strategy. Instead of trying to make a perfect API call that gets a 200 OK, which would mean setting up complicated mock data, we do something way simpler. We just check that the server doesn't reject our request with a 415 unsupported media type error. This is genius because it keeps the tests laser focused on just one thing, the content type, and lets us use super simple dummy objects for everything else.
Okay, so generating hundreds of tests with a few lines of code is awesome. But it creates a new problem, right? A test report that's a mile long and just a total mess to read. Let's fix that.
So, without any organization, your report might look something like this, just a flat list. If you had 2 endpoints, no big deal. But when you have 50, trying to find a specific failure inside this wall of text is an absolute nightmare.
And this is where our other building block, dynamic container, saves the day. Its entire purpose in life is to act like a folder. It lets us group our related dynamic tests together under one name, giving our reports some much-needed structure.
And boom, with that one little change, our chaotic flat list turns into this beautifully nested, easy-to-read report. Now all the tests for /API users are tucked away neatly, and all the tests for /API products are right below them. It's clean, it's clear, and it scales perfectly no matter how big your API gets.
So, we've seen how powerful dynamic tests can be. But maybe the most important question of all is, when should you actually use this in your own projects?
Well, it turns out there is one single, unmistakable signal that should tell you, hey, maybe I need a dynamic test here.
This is it. This is the golden rule. The moment you find yourself highlighting a big chunk of test code, hitting copy, and getting ready to paste it somewhere else, just stop. That's your brain screaming at you that you have a repeatable pattern. And that is the signal. That's when you build a factory instead.
And once you start looking for this copy-paste smell, you'll see it everywhere. Think about security checks, right? For a dozen different endpoints, you need to test that an admin can get in, but a regular user can't. Or database tests, verifying that an operation fails if a required field is null. Anytime you have these standard checks that apply across many different parts of your system, you've found a perfect use case for dynamic tests.
So I'll leave you with this question. Think about your own project right now. Where are you doing that copy-paste-modify dance? What's that one boring, tedious testing task that you absolutely dread? Because that's your target. That's the toil you can automate away by building a factory instead of just another test.